guys, in this video, we will be proving that 2 to the power of n plus 2 plus 3 to the power of 2n plus 1 is divisible by 7. To prove this, we will be using the principle of mathematical induction. Let's start!
The first step is to show that n equals 1 is true. Basically, what we're trying to do here is to prove that the first term of the statement is true. Doing a substitution, we have 2 to the power of 1 plus 2 plus 3 to the power of 2 times 1 plus 1. Simplifying the exponent, we then get 2 cubed plus 3 cubed. 2 cubed is equals to 8 plus 3 cubed is equals to 27. Adding 8 and 27, we have 35. And since 35 is divisible by 7, that means when n equals 1, the statement becomes true.
For step 2, we need to assume that n equal k is true. That is, 2 to the power of k plus 2 plus 3 to the power of 2k plus 1 is divisible by 7. We could then make an assumption. We let 2 to the power of k plus 2 plus 3 to the power of 2k plus 1 equals 7p. For all p element of integers, this assumption will be used in the third step.
In the last step, we must show that it is true when n is equal to k plus 1. With that being said, we must show that 2 to the power of the quantity k plus 1 plus 2 plus 3 to the power of 2 times the quantity of k plus 1 plus 1 is divisible by 7. In order to solve this, first, we must first simplify the exponents. 2 to the power of the quantity k plus 1 plus 2 is equal to 2 to the power of k plus 3 plus 3 to the power of 2 times the quantity of k plus 1 plus 1 is equal to 3 to the power of 2k plus 3. In order to achieve our goal, we could do a little bit of mathematical manipulation. We could apply a law of exponent about multiplying powers with the same base. In this law, it states that in multiplication of exponents, if the bases are the same, then we need to add the exponents. Here in the first term, 2 to the power of k plus 3, we could rewrite it as 2 to the power of k plus 2 times 2. Note that there is an exponent of 1 in every whole number, and if we multiply this, it would be equal to 2 to the power of k plus 3. Same as the second term, 3 to the power of 2k plus 3, applying the law of exponents, we could rewrite it as 3 squared times 3 to the power of 2k plus 1. Next, we could manipulate 2 using the principle of subtraction and rewrite it as 2 to the power of k plus 2 times 9 minus 7. Note that 9 minus 7 is equal to 2, so we did not violate any mathematical rule. Then copy plus 3 squared times 3 to the power of 2k plus 1. By distributive law, we could distribute 2 to the power of k plus 2 to the terms in the parentheses. Doing that, we have 9 times 2 to the power of k plus 2 minus 7 times 2 to the power of k plus 2 plus 9, because 3 squared is equal to 9, times 3 to the power of 2k plus 1. Looking at these two expressions, we could put this term in the same parentheses since it has the same multiplier. Doing that, we could get 9 times 2 to the power of k plus 2 plus 3 to the power of 2k plus 1 minus 7 times 2 to the power of k plus 2. Looking at this expression, notice that it is familiar since it is our assumption in the second step. So with that being said, we could substitute it as 7p. So doing that, we then have 9 times 7p minus 7 times 2 to the power of k plus 2. Then 9 times 7p is equal to 63p minus copy 7 times 2 to the power of k plus 2 since we cannot multiply these terms due to the variable in the exponent. We could then factor out 7 from this. And then we have 7 times 9p minus 2 to the power of k plus 2. We can already see that it is divisible by 7 because if we divided 7 by this, we could get a whole number. Hence, 2 to the power of k plus 1 plus 2 plus 3 to the power of 2 times k plus 1 plus 1 is divisible by 7. Consequently, we could therefore conclude that it is true when n equals k plus 1.
Since we have already proven that it is true when n equals 1 and n equals k plus 1, we could therefore conclude that by principle of mathematical induction, 2 to the power of n plus 2 plus 3 to the power of 2n plus 1 is divisible by 7. End of proof!